Hi everybody, this is Mr. Zarzak and welcome to Physics Underground because we're in my basement. Today I'm going to be talking about curved mirrors, and I have two types of mirrors to show you today. On my left I have the convex mirror, and on my right this is the concave mirror. So let's get started.
Okay, so we're going to start with the convex mirror here. Before we get into what it does, let's talk about why its name is called convex. The convex part is its shape. So if I hold it sideways here up to the camera, you can see that the mirror itself, it bulges outwards here, so it's thicker in the center, and that's what convex means. Okay, so the direction of the curvature is outwards in the middle of the mirror. Okay, so that's the idea behind its name. It has another name. It's called diverging. Diverging is what it does when light strikes it, which is it's going to cause light to get spread out, okay, from a point. But we'll come back to that idea a little bit later on, okay? And for now, enough to know this is the convex mirror. Okay, so I'm sure you've seen these things in plenty of places, whether they're in a convenience store or at the end of a driveway or on the front of a school bus or mounted on the side mirrors of a car. Okay, well, there's a reason that we use these things, okay? And if you look, I've got this set up so that you can see. If I just kind of zoom in as close as I can while still keeping the mirror on the screen, you can clearly see the bowling pins being reflected on the left, and that there's a little Pac-Man light that I have being reflected on the right. So we can see both those things, okay? So what I've done here is I've set up a plane mirror right along with the convex mirror, and the plane mirror is just as wide as the convex. In fact, I think it's actually even just a hair bit wider, okay? But what I want you to focus on now is the field of view, okay? How much you can actually see with the mirror, okay? So you can still see the Pac-Man light on the right and the bowling pins on the left. Now, let me come in and get down so that I'm eye level here, okay, so that you can see both. All right, so you can see the bowling pins on the left and then the Pac-Man light on the right. But if we look down here, okay, look at how much narrower our field of view is. If I look here, focus on the left side of the plane mirror, you can see that there's this gray post, okay, that's used to hold up part of my ceiling, and that's about the limit of what you can see with the plane mirror. Look where that gray post is in the convex, okay, and the same thing on the right-hand side. In the plane mirror, you can just see the beginnings of the kids' playground set in the background on the right, but then if you look in the convex, you can see the whole thing. Now, that's really why we see them on buses and at the end of driveways and in convenience stores, is because they expand out our field of view. We can see more, a bigger range of angles of view with this mirror, but of course the trade-off, as I'm sure you're well aware, is the size. Okay, if you compare the image of me in the convex mirror versus the plane mirror, I'm a lot smaller in the convex mirror, so we lose magnification. Okay, and the reason that this happens is because the convex mirror literally takes the field of view and it squeezes it so that we can fit more angles into the same surface of mirrors, okay? And the reason that this happens is because of its curvature. Okay, so I replaced the flat mirrors that I had, or the plane mirror that I had set before horizontally for this one that's vertically, to demonstrate something, a different property of the convex mirror. Okay, to understand what I want to show you with the convex mirror, we go back to the plane mirror where the image distance is always equal to the object distance. And so the image that you're seeing of me being reflected off the mirror into the camera is actually located somewhere behind the mirror, just as far as I am in front of the mirror. And so if I move forward, okay, you can see my face come into view. As I move closer to the mirror, so too does the image of me move closer to the mirror. Okay, so then I'm going to take away this plane mirror, okay, and I'm going to replace it with the convex. All right, now with the convex, hopefully you can see me standing out here in front of the mirror. As I get closer, okay, and I come on camera, all right, what I want you to see is that, yeah, I do look smaller, but if you focus, you can kind of see this. The image of me is actually closer to the mirror than I am right now. So that here we said that the image distance is less than the object distance. Okay, and like I said, you got to kind of stare at this for a little while to see it, but go ahead and pause the video, okay, if necessary, just so you can see this, that the image of me is shrunken down in all three dimensions. So like I'm smaller this way, but this dimension, depth, is also shrunken down too, so that the image of me is actually closer to the surface of the mirror than I am. It's just located behind the mirror. Weird, but really cool. Okay, next up we have the concave mirror. The word concave has to do with the shape of this mirror. All right, so if I hold it up to the camera here, you can see that the way that it curves is it curves inward like this. Okay, so like the center of the mirror curves inward. And so if you watch the previous video on the demonstrations from practice file 8-1, okay, you heard my memory trick. The way that we remember the difference between concave and convex is that the concave, it bends inwards, almost like you're going into the opening of a cave. Okay, not glamorous, but effective. All right, and so let's see what this mirror does. Okay, hi. So here I am in front of the concave mirror. And as you can see, the image of me is pretty small, so you might not even be able to tell. I'm trying to wave here. Okay, so you can see I'm upside down. Now next to the concave mirror, I have a plane mirror, just so you can see how big my reflection, the image of me looks in the plane mirror versus in the concave. Remember that with the plane mirror, the object distance and the image distance are one and the same. And so with the concave here, I'm actually much farther away, which is why I appear smaller. Now as I move closer, okay, it'll become a little bit easier for you to see that I'm farther away, but you can see that the image of me is getting bigger. And as I get closer and closer and closer, okay, well then the image of me in the concave mirror, the size of it versus the good old plane mirror, okay, it's pretty much essentially the same now. If I continue to move closer, you'll see that the image of me gets really, really big, okay, as compared to the size of the image that you see in the plane mirror. And so with the concave mirror, okay, I get this inverted image. It's upside down, all right, and the size of the image really depends upon how close you are to the mirror. It can be bigger than what you get with the plane mirror. It can be smaller, or it can be the same as well. Pretty cool. Okay. So something else I wanted you to see with the concave is that if I use my finger, okay, well the image that we see in these mirrors looks a little weird. Not just because it's big, all right, but some of you might pick up on this. The image is actually looks like it's coming out, almost out of the mirror. Okay, and the reason is because this is the first case where we have an image form that's what we call real. Believe it or not, the image is actually being projected out in front of the mirror, and so that's why what you see looks so strange. It's not just that it's big, but the image of my finger is actually coming out of the mirror. To produce what we call a real image. And that's, like I said, that's really strange. So I've got some demonstrations that I want to show you now to help you hopefully understand what I mean by a real image. Okay, one that's produced in front of the mirror and has this special property that it can be projected onto a screen. Okay, so let's check that out. Okay, so what I have set up here is I have this really bright light. In fact, when I use it for the demo, I'm actually going to take this shade off so that it's even brighter. But even just with a little bit of this, you can see that the reason I have this is so that I can get a lot of light, okay, reflecting off of my hand or whatever I want to put on top of this, okay? And so what I'm going to show you is what happens when I take and I put an object in front of, this is the concave mirror out beyond the focus point, okay? And what I want to focus on is what you're seeing on the wall here. This, ladies and gentlemen, is an image of my hand. Okay, this image is being projected onto the screen, which in this case is just my wall. Okay, and you can see me wiggling my hands here. All right, if you can see this, I've actually got my hand pointed with my thumb up, whereas the image that gets formed up on the screen here, up on the wall, my thumb is pointing down. And I can do this with whatever I want, see, because with the concave mirror, the images that get produced, if the object is placed beyond the focus point, those are what we call real images, but they're also inverted or upside down. So like I have this little, I found this this Pac-Man light, okay, that you can see, and you see I've got the Pac-Man, his eyes are on the bottom, so the Pac-Man is upside down. If I take and I produce an image of the Pac-Man up on the wall here, you can see that the Pac-Man is actually right side up. Okay, and what's really happening here is because the object is upside down, when the image that gets produced gets flipped upside down, get this into focus here. Oh, I lost it. There it is. When the image that gets produced is flipped upside down, we've got like a double reversal here. Okay, so pretty cool. One more time with my hand. Where is it? There it is. Okay, that's a real image being produced onto a screen. Okay, so just as another example of a real image, this little toy that I'm holding here, it's called the Mirage. This is a toy that is on loan to us from Mrs. Zarzak. We have a couple of these back at school, but we have one at home, and it's hers. So thank you, Mrs. Zarzak. Anyway, so if I rotate this around, you can see that it looks like what we have here is a little toy pig sitting on top of what looks like a convex mirror, but that's not really the case. What you're really looking at is a real image of this pig. So like if I take my finger, I can actually pass it through where you see the pig, because, well, the pig's not really there. Okay, what you're seeing is a real image that's being formed out in front of a concave mirror. And so what's going on here is on the inside of this, we have a concave mirror, and the little piggy, the real piggy, sitting down here, down at the bottom of this, and you can actually see the pig is backwards. All right, it's because everything with real images are reversed, so they're inverted. So it means they're flipped both sideways and up and down and forwards and backwards. So you actually put the little piggy in. If I put the face of the piggy in here in the center, and then I put the other concave mirror up here, okay, the image that you see is reversed. So you see the back of the pig instead of the front. Okay, but again, it's just an image. So it's like I can take my finger and make it appear like it passes right through, because it's not really there in the sense of that it's not a physical object. It's just a real image that's being produced out here on top of the mirror. That's kind of amazing. Okay, and that's what we mean by real images.
Okay, so just when we thought that this couldn't possibly get any weirder, well, look what happens when I scooch closer to the mirror. Sorry for the shaky camera work, but at some point this image of me, it seems to disappear. I don't really see anything else except, wait a minute, here I am again. What's going on here? I'm huge. What's going on here? I don't like this.
Okay, so what the heck is going on here? Well, it turns out that once I move inside the focal length of the mirror, the behavior of the mirror changes. And so here, I'm nice and close to the mirror, so if I look into the mirror, okay, you should see me as really, really big. What's even weirder is that I'm now right side up, and as I get closer to the mirror, the image of me actually starts to get smaller. I can actually make the image of me appear bigger by moving farther away. This is weird. This is really weird. Such as the concave mirror. Okay, so now let me show you approaching the concave again, but this time, let me just turn the camera around so you can just see me holding the camera in the image that you get when looking into the mirror, both of me and on the video of the iPad. So let's just get a little closer here. Get a little closer here. Oh, what is happening? All right, so hopefully you can see that behind the iPad there's me, and you can see on the iPad too, right side up and magnified. Whoa, and if I bring in closer, it gets smaller. If I move it farther away, it gets bigger, and at some point I reach the focal point and everything just kind of disappears altogether. I don't know if I'm upside down or right side up. What I do know is that this is Physics Underground with Mr. Zarzak. Thanks for watching, and we'll see you next time.